Okay, in a previous video on the API, we discussed how to make this button affect that rotating needle. We did that by connecting to some external code that we wrote in C, and we compiled as a client executable, which we ran as an active client against this session of Altia design. So it's C code in the API that's powering this right now. What I want to do is reproduce this very behavior in Altia control code instead of using C code. And this will just kind of give you a comparison, as well as highlight the fact that you can use control code or C code or both, depending upon your needs. Control code is a nice, forgivable, sort of fill-in-the-blank programming language that does not need to be compiled. But there is a lot of mindshare in C code, and you can do things like check C code into source control systems and things like that because it's external code. So before I get into writing the control code, let me just show you what the C code did. It basically created an event listener for audio button press. It did that by registering a callback for audio button press, saying add callback. That's an Altia API function that listens for a value change of audio button press. If a value change does happen, it calls the callback function here, and it says, hey, if audio button press is equal to 1, value equal 1, right? Increase speed with send event by sending speed the value of I. And what is I? Just being changed by this simple for loop. In a real world situation, a motor controller might say the actual speed of an engine, but for this example, it's just a for loop. So it's basically going from the minimum 0.0 to the maximum 0.280, rotating it up, right, or clockwise. If the value is not 1, audio button press is equal to 0, we're going to rotate the needle from 280 to 0 or maximum back to minimum. Again, just sending the value to speed. That's the C code. It's working now because we're connected to that client. Let's disconnect the client and reproduce this very same code in Altia control code. Okay, so I'll come here to client, say disconnect all, and if I click the button now, there's nothing going on. That's because that C code is no longer powering our interface. Well, we need to write some control code to make it come back alive, right? 2 user tips. 1, when you're writing a lot of control code, I like to make logic blocks, and what I mean is just a label and a rectangle. And I put these at focus level 0, and what I mean by focus level 0 is the top level of your entire GUI. That way, no matter how complicated your GUI is, you don't have to like start digging into your model to find where your control code might be on some child object, or using find to search your entire model for control code. Instead, you know that most of your control code is at these top level logic blocks, and so you could just write control on that. That's a user tip. It's not a requirement. It just makes things more accessible to find your code. To write control code, you bring up the control code window, and that is done from Windows Control. Here's my second user tip. I like to keep control as a non-docked pane because I like to have it float over when I'm writing code and be completely gone when I'm not. And it also gives me a lot more room as a non-docked pane just floating. And I can resize it if I have a lot of code or do whatever I want. So that's user tip number 2. All that said, let's write some control code. And the control code we're going to do is the exact code that we saw before, only not C code. It's going to be control code now. I'm going to write with code assist turned on, and this is a great feature that basically fills in the blanks, or provides blanks for you to fill in, I should say, as you write your control code. Control code always starts with these root level commands, a when or a routine. A routine is a branching statement. It's going to go into this routine, do its stuff, and come back. A when is the top level command that is just event listeners, and they're kicked off as they queue up. So what do we want to do to listen for an event? Well, we want to when what? When audio button press. Okay, that's just like add callback in the C code we just looked at. When audio button press equals, I'm going to leave this blank, and that's just bracket down in raw code form. I'm going to leave it blank because I want it to listen for any value of audio button press. Okay, and then I could click add and choose from here, or just as easily click over here. And I want to click over here to select an if. If what? If audio button press, audio button press, and maybe I'll put this in my copy buffer there so I don't save some time. If it's 1, right? Then we add, and what are we going to do now? Well, here's that loop, right? So we just add a loop, right? This is the condition. We were saying speed is less than 280. because that's our max. So while you're less than your max, go ahead and increase it. How do you increase speed? Use an expression. You just say speed plus 1. Okay. Notice everything's yellow. That means it's uncommitted control code. What I mean by uncommitted is if you're not using code assist, or even if you are, you could have some syntax errors or bad indentation. Apply actually commits your statements and checks for errors, and they will show up here if you did make some errors. I'll intentionally make some errors coming up when I'm writing code, so you can see that, but just want to make sure that you know to click apply to commit your control code statements. Okay, well, notice that the commands that I can choose from here are grayed out, some of them, and that's because I'm at an expression level. I'm not at the if level. So to get back to the if level, I actually have to click end a couple times till I can see, you know, okay, I'm now back at the if level. I can choose an else. Well, I'm going to choose an else, and then I'm going to copy a condition so that I can cause an error here. All right, so I just click else, and then I'm like, okay, I'm just going to copy and paste this code here. Control C, and then come down here. Oh yeah, I can't paste because I'm in code assist, so I come out of code assist. I think I'm being smart, right? And paste it, and I click apply. Warning, right? Well, remember I set that up. Here's the error system. It's going to tell you what line it is, and you know what the problem. It thinks the problem is in code assist. This is pretty cool. If you click code assist with an error, it says else has no parameters for this statement. Well, I gave it a parameter, and that cues my memory to go, oh yeah, I was thinking else if. So I can come in, I could delete that statement in code assist and redo that with an else if, or I could come back to outside of code assist, just add if and click apply. And now it's happy. Now it says, okay, you can do an else if audio button press. You just cannot do an else audio button press because else has no comparisons, no parameters, right? Okay, so the only thing I need to change here is else audio button press equals 0. And here is where I'm going to click apply and now just do some raw typing. So not code assist. Okay, and here you can just say loop speed greater than 0, and it's up to you how you code and control code. Maybe you're faster at typing than you are filling in the blanks of code assist. And then of course keyboard shortcuts. You want to do control P for expression. They're shown right next to the statement, of course, here. Okay. When you're raw typing, you do have to match the syntax. Okay, which code this helps with, but I'm just going to look up there, but I also know the syntax. But if you're new to this, just look up here, look at an example, or go to code assist. But we just want to reverse that expression. So speed -1. Okay, and what we've done now is reverse the loop and reversed the expression. Okay, and then just, you know, if you're raw typing in Altia control code, it's good to click apply occasionally, see if everything's okay. And it had a blank line, so it just added a comment. That's fine. But no errors, so everything's good so far. And again, I can just click end to get out, you know, of my structures here, and click apply. Now, this is complete. This control code is done. Half of it I wrote freeform, half of it I used with code assist. When you get familiar with writing control code, you can do this a lot more quickly than I did, because you won't be explaining each step and bouncing between the two modes. You'll just do what suits you the best and what's quickest for you. But keep in mind that I'm not going to compile. I'm just going to enter run mode. But the only thing I want to do before entering run mode is review what we got, what we just wrote. We wrote the control code equivalent of the C. When audio button press equals anything, if it equals 1, for speed less than 280, increase speed +1. All right, and then audio button press is equal to 0. Go ahead and while speed is greater than 0, decrease the value of speed. Okay. All right, so basically the same thing as the C code, just once again, the control code equivalent, click the button, and now we have control code doing what our C code did.